Yo, what's up? Welcome back. Today we're working on my stream intro screen. So that's showing on the screen right now. We have this like text that's being rendered, and every once in a while it looks like somebody's like backspacing out and saying how long till the stream starts, whatever. There are reasons that having this guy up is useful in in the streaming world, but I don't really want to get into it. The idea is mostly now we want to like make this more interesting, and we were kind of exploring this like idea of maybe like doing like a little 3D scene where we have like the same concept where we have like a computer screen and somebody's typing into it, but instead of like it being just flat on the screen like that, it would be kind of fun to like position a camera like something like this and like have the text like on the screen, whatever. You could have like some like fun stuff in the background, like a little coffee cup or whatever, and like you'd have some animations going, whatever. It doesn't really matter. But the idea is that we want to have like some form of like 3D, and we're using that as an excuse to explore like making an OpenGL renderer and like kind of seeing like what goes into like drawing a complex, or this is a complex scene, but like a slightly more complex scene in 3D, like more than just an object. Yeah, so that's what we're looking at. And where we're at right now is we have last stream we kind of implemented like rotation and import of like arbitrary 3D objects. So we have this like monkey head that's imported from Blender, and we've got all of his faces drawn in the right way, and you can see him like spinning in a circle around some arbitrary point, which is pretty cool. We don't have any like concept of translation right now. We don't have any concept of like camera movement, so the camera's in like a fixed position and this guy is moving in world space. It'd be nice to be able to like have the object be like quote unquote stationary and have the camera move. In reality, like moving the camera, moving the object are kind of the same thing. But how we think about it is slightly different. So it'd be nice to support some form of like camera positioning. And if we get to the end of that, maybe we'll work on like texturing, right? So this guy just was like a white blob. It might be nice to have him like look like something. I'm not sure if I want to do that, or maybe we'll find that it's hard to like position things in the world. So we might want to like have like saved positions that we can like import in some way and maybe some sort of editor. I don't know. We'll see where we get. But the first thing we want to do is definitely like finish up like object coordinates and like transformations and stuff like that. So where did we get to last stream? We were probably in our like, we called our thing cube renderer because initially we were rendering a cube. This will have to be adjusted to be like 3D mesh renderer or whatever. And we are passing in what looks like to be rotation matrices. So 3x3 matrices that are applied to a 3-dimensional coordinate that specify its like rotation. Let's see. Let's look at our 3D vertex shader. And yeah, he's taking in a rotation matrix that we incorrectly named Z rotation. So let's just quickly fix that. Start and run, make sure that still works, and we'll adjust the time. We'll pretend that we're starting stream at 3, even though we know we're not, just so that we have a different line. He doesn't like that. I forgot to adjust the name over here as well, so let's just fix that as well. Okay, there we go. Yeah, so we're passing a rotation matrix, and we've been kind of like slowly building up the idea of transformation matrices, kind of like from scratch. So we kind of started with the idea that in 2 dimensions, a rotation can be defined as like, say I have a point X here, or point here. This can be thought of as like a translation along X and then a translation along Y. And if you kind of like rotate this whole thing, you end up with something that looks like, say we were like rotating it and we wanted it to be like rotated by 30 degrees or something. You have like these new arrows here and here, right? That are kind of like the same length, but now they're in like a new coordinate frame. So you can kind of like figure out what these distances are in like the new X by adding up this and this, and you can figure out its Y by adding up like this and this. So you can build up this like kind of like rotation matrix out of that, and that extends into 3 dimensions. They compose well, and that's how you get this like 3x3 matrix. Is basically you're doing these like sines and cosines that define these rotations, but you're doing it in 3 dimensions. And now if we want to start adding in like the concept of translation as well, that's where like this concept of four dimensions on your coordinate makes sense. So you have like here we can start defining our matrix. Instead of a 3x3 matrix, which is a rotation, we can define a 4x4 matrix, which is rotation plus translation. And the way it works is that you like shove your rotation matrix up in the corner here, and then you have like one more column that is like translation in this area, and then you just put a 1 here. And the reason this works is because you're going to multiply this by a like vector that looks like x, y, z, 1. And so when you like multiply x, y, z, get like put into this rotation matrix, and then you basically multiply all these translations by 1. And so when you add those back in, now your x has moved by whatever you put in here exactly. Your y is moved by that much, and z is moved by exactly, because it's just like 1 times the translation that's added on to the thing. And this has like those like same nice properties where if you multiply these like matrices together, they end up following the same pattern. So we need to like implement that in our little renderer here. So we implemented like a rotation matrix that really is just like any 3x3 matrix. We're calling it a rotation matrix, so we don't have to think about anything else really. And we can kind of just do the same thing, and we'll implement the like 4x4 matrix, and we'll call it transform. And this is the same thing where it's a bunch of floats, but they're 4x4 instead of 3x3. And we'll probably want to do the same multiplication implementation and like the new implementation where there's like extra work that's going to have to go into here later, but we'll just use this as a starting point. And all of these need to be adjusted. These like multiplication coordinates, they need to be, these like iterations that we're doing over our axes for multiplication of or the dimensions of our matrix, I should say. These guys need to have their sizes updated, so we'll just do that real quick. And I actually don't know if this same multiplication formula works out. I think it does. So really we should have just like a generic matrix multiplication function, but for now we don't have to, like, that's too generic, harder to think about. Maybe it's not. Yeah, I don't really want to think about like the generic implementation, so we'll do this for now. We'll just do a copy paste, and we'll throw a little fix me on this and say duplicated. And probably just to make sure that like that is correct, we can add a test for simple multiplication transform, and this one is simple multiplication rotation. And we just want to do the same thing that we did last stream, where we pick up Python 3, Python 3 and NumPy, and we can just like do a matrix multiplication in Python land and copy the results over to our test to make sure that our matrix multiplication is doing what we expect. So we can say Python, and we can say import NumPy, and we can define a matrix A, which is like a NumPy array, I think. And we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, and 3, 4, 5, 6. Okay. So A is this now, and then we can say B is equal to A plus 1. So B should be something similar, just another pattern, and then we could do A times B, or is it A at B? Which one of these is which? Shit. What did we do last time? Let's just double check. NumPy at versus times. There is no difference. You can take additional optional arguments. Why am I getting different numbers then if I do A times B, A at B. I'm just getting like totally different numbers. What do we expect to happen here? Matrix. Oh, here. This will tell us. Oh. The star is element-wise, so we want A at B. I think. Mat mul. Multiply in terms of array broadcasting. Yeah, I think we probably want matrix multiplication. Yeah. So let's just copy these guys out. So we have array 1, which is this. I guess we can quit and we can just kind of copy a whole chunk of this guy out, and we'll go into our test and just paste here and pull out what we need. Okay. So we're going to have one is transform A and transform B. Transform A, transform B. And here we're going to have to copy paste this guy in. So this is going to be, if I press J here to join them, nice, that gives me what I want. And then I can yank everything in here, paste it here. And then I have to map all of these elements to be floats. So is there a quick and easy, dirty way to do this? I can probably like find all 0 to 9 sequences in here and replace them with 0 to 9 sequences followed by 32F. I think something about this is not liked by, I think I'm using like the wrong regex in here. So we'll just say 0 to 9. If I do 0 to 9, star, no, plus, no. There's a way to say like 1 or more in regex, and I can't remember, fuck. Regex 1 or more. I could have just typed them all out now, but now I don't want to do that. It's a plus, yeah, so I should be able to in Vim say 0 to 9 plus. But that doesn't seem to be working. Oh, I have to escape the plus. I see, of course. And then from there, we can put this in brackets, which I think you might have to escape the brackets too. Nice. And that will say, like, capture these guys. And so let's go back to my little search replace, and we'll do that in there. So we say this guy is going to be replaced with thing I see dot F32. And we can do that multiple times. There we go. That's not bad. Oops. Yeah, that works. Okay, so we'll do the same thing for B, where we copy paste this array. We paste them here. Delete all of the extra shit. Clear this selection thing so it looks less garbage. And apply the same regex. Nice. Then we're going to have some sort of like expected output, which is going to be a 4x4. And here we're going to do the same thing where we copy out this guy, paste him, delete, join, search, replace, clear these, highlight, there we go. Okay, so hopefully this passes, but we'll find out. I'm pretty sure this should be right. Cargo test. Yay, let's go. Looks like we're good. BTW, you don't have to specify F32 for every element. It's enough to do enough that something specifies F32. F64 is default. The only you need a dot somewhere in the number. That's a good point. I think I'd rather because like it'll like coerce the rest of the matrix or the rest of the array. I think I'd rather have all of them, but I can see what you're saying. Yeah. Okay. So we have extended to a 4x4 matrix, and probably we might want to like add functions to like pull out rotations and translations manually. But for now, let's just kind of go back into our little render function and add in like a bounce to the left and right of this guy. Well, first let's make sure that our the fact that he's rotating right now kind of like sorry, let's run him and you'll see what I mean. Right now his like rotation like around the vertical axis seems to be like not centered on the guy, which I don't really like. I kind of want it to be like centered on him. So it's possible that like his vertices are all not centered correctly. So I want to like double check the object that we're importing and just make sure that that's right. Why never her? That's a good question. Maybe it's a girl monkey. It's because in my head, everyone in programming is a guy, which is just not really true. You're right. I should vary it up. So if I import this guy from wherever we're storing him, or her, as pseudo chop wants, we can see that like they're not centered correctly. So we can say object set origin to center of mass by volume. Let's see. So if I rotate this around Z, that looks pretty fine. Yeah, we can call that a day. So let's also reset his position, which I can't remember how to do. Right click, object, clear. Here we go, location. Okay, there we go. So now when if we export this one, we should see a rotation that looks a little bit more reasonable. Yeah, okay. So now there's no like movement in here like we expect. And now we can try to like tack on some movement as like an extra thing. So let's kind of like just have them bounce like back and forth or something just to prove that we got our transforms correct. We've got like our concepts down. So I guess in our vertex shader, we're going to need to apply not just a rotation, but a transform as a whole. So we'll just throw this guy as a mat4. We'll rename him to transform. And everywhere we have rotation, we will now say transform. And instead of applying it to only XYZ, we'll apply it to the whole vertex. And our vertex will now need to be a 4D thing. So we're probably going to have to say our in vertex will still be in 3 dimensions. Is that true? No, he's already in 4. So we actually can just use him as is. So this is our outvert is our invert. This stuff looks like it all lines up. Just here, we need to say GL position is equal to outvert. And the color can still be this, except we should scale it relative to the fourth dimension now that we're using that. We're like homogeneous coordinates that OpenGL use are supposed to be like first 3 dimensions, or the first, I shouldn't say dimensions, the first 3 elements over the 4th one is how these are calculated. Okay. So he doesn't like this because uniform variable transform must be a constant expression and too few components to construct a mat4. So this guy needs to have some zeros on the end. He needs a 0 here, and he needs a 1 here on the diagonal. So this is essentially saying like, hey, don't fuck up. Don't fuck up anything. Like just the 1s on the diagonal will like leave everything as is. Okay, so we are missing some commas here, which it doesn't like. And now we're getting to the point where we're trying to find the rotation here. And so we just need to say this is now transform. So this should now compile, but we're going to be uploading like an invalid matrix to him, so we have to fix that as well. So first, let's also rename this like Z rotation to be transform loc, because that's a more correct name. There we go. And now we just need these guys to, instead of being rotation matrices, these are going to be transforms. And each of these guys needs an extra 0.0 in him. 0.0 and an extra 0, 0, 0, 1. And let's just do the same thing for the first rotation. So this guy needs a 0.0. This guy needs a 0.0. This guy needs a 0.0, and we need a 0.032. And a 1 here. Okay. So does that do it? Hopefully, this guy is now no longer uploading a matrix 3, he's uploading matrix 4. And I think probably the rest of this kind of all just lines up. He's still not doing any rotation, so something's wrong here. Something is not right. So combined should be a transform, which is a 4x4. When we put this guy up here, we should see transform location. He should be putting up combined array 0. This needs to be 12. Now, he's no longer 3 long. He's 4x4, but that's not fixing it either. So it would be interesting to maybe see. Let's see. How can we debug this? Let's print line. Let's like see what this combined matrix is and see if it looks like something reasonable. He doesn't like that because transform doesn't implement debug. So we'll just quickly throw a little drive debug on there. Okay, so this array seems like hand wavy. We are seeing movement in this guy. He is rotating in some way. And we see that like the fourth column is 0, 0, 0, 1. So that all that seems reasonable. It's possible that we are supposed to specify that we there's like this upload uniform function. He has this like invert thing going on, and maybe we got that wrong, but it doesn't look like that's it either. Okay, hold on one sec. I accidentally lost a window, so I'm just opening it again. Okay, what if we tried to do something a little less complex? Let's say that we ignored all of this translation stuff, and we only let's think. I want to go back to maybe a more simple thing, and let's start with like what should be identity matrix, like this. Yeah, this is what I'm looking for. Where we have a diagonal that changes nothing, right? We just have 1, 1, 1, 1, and then maybe let's do something like move him along the x direction over time. So we can say like, instead of our rotation being used as a rotation, we'll just have this number that we know is going to move, and we'll try to move him up to the right. Do we see any movement over time? And the answer is no. But if we go back to printing this guy, we should see him like advancing. Yeah, we do. We do see him like advancing this one thing. And that's doing like fucking nothing. So the question is like, why? It must be some sort of OpenGL integration issue. So we can maybe go back to our vertex shader and maybe like double check what we're doing here. And maybe we can do something like adjust the color over time with his position. So just to see, like, we want to make sure that the shaders are still like running successfully, I guess. So So here I've adjusted it so that he's moving to the right over time. And I guess what we want to see is we want to see that we see his color changing over time if we look at that specific value in the transform. So if we looked at like color is equal to vec3 transform 0, 3 minus 1.0 to get him into a better range. I want to see that like over time his color is changing, and it's not. So I wonder if it's 3, 0 instead of 0, 3. Let's just double check the order here, and that's also not changing over time, which is kind of interesting. We would expect that if our code was running successfully, over time we would start to see this number increment, and that would turn into a color change on him. So my guess is that, oh, I fucked up again. 12 isn't 4 times 4. 16 is. Okay, there we go. We start to see him move now. And it's hard to track that. So I guess we'll also put him in the range. We'll force this into the range of 0 to 1. So we'll do something like let movement is equal to, is there like an F mod in here? I think there's percent will give you remainder here. So we can just say rotation degrees percent 1.0. Then we can say that this is movement, and probably everything else just kind of lines up. There we go. Okay. Yeah, that's working. And is this 3, 0 that we should be seeing? I guess our movement needs to, this probably needs to be absolute valued as well. So we'll say abs. F32 abs, because I think he's moving in the negative direction instead of positive here. Okay. And we're still not seeing color. So 0, 3. That's, oh, we've also got a minus 1.0 in here that we don't want. Okay, let's see. Do we see his color changing over time? No, which is still wrong. We would expect him to turn white as he gets to the edge. There we go. Okay. Okay, so that's kind of giving us a bit of an indication of what we should be expecting here. So the fact that this is 3, 0, not 0, 3 is kind of interesting. I guess that means that this inversion here is important. Yeah, okay. So we are storing our matrices as like, okay, so these are like 2D grids of numbers, right? Like A, B, C, D, E, F, G, H, ... right? And the way that we're storing these in memory is like, once these get mapped into linear memory, like A, B, C, D, E, F, G, H, but it looks like OpenGL is storing them the other way. They're storing them as like, I guess we have to write more of these out. E, F, G, H, I, J, K, I, J, K, L, M, N, O, P. OpenGL is storing it, it seems like, as A, E, I, M, then B, F, J, N. Like it's going this way instead of this way. Now that doesn't mean that they're like using the numbers any differently. It just means that like their memory layout is the other way. So they're expecting us to do like X position, Y position, and we are storing it in YX. So that's why this like flip thing exists. So let's actually double check that I understand that correctly. So we're going to look up this API, uniform matrix for F32 slice, which probably comes from like GL uniform matrix for FV or something. GL uniform, and these matrix ones have a transpose field. And what does it say about those transform field or transpose? What does it say? For the matrix command, specifies whether or not to transpose the matrix value as the values are loaded into the uniform variable. That doesn't really help us, right? We don't. I understand that that's going to do like a YX to XY flip, but I want to know like why. So I think they call it like column major order. Row and column major order. Yo, what's up? And so this is kind of essentially the same thing that I was just saying, where you can either store them as like X first or Y first. And I guess we can look up open GLSL column major. Matrix notation used in OpenGL documentation does not describe in-memory layout for OpenGL matrices. Okay, so I guess I'm wrong. It will be easier to think about, easier if you drop and forget the entire row column major thing. That's because addition to row column major, the programmer can also decide how he wants to lay out the matrix in memory. OpenGL matrices have the same memory layout as DirectX. So this goes, so he's saying they go left to right. But that doesn't line up with what we just saw. Right? What we saw is that our matrices aren't behaving as we expect. But I guess it could be that we expected our vertices to be like a column, i.e. multiplied row by row, but maybe they're actually a row that are multiplied column by column. Oh, this guy, I'm going to update this 9-year-old answer. A mathematical matrix is defined as m by n, where m is the number of rows and n is the number of columns. For the sake of completeness, rows are horizontal, columns are vertical. Blah, blah, blah. When we denote a matrix, the first element is row index, second was column, so blah, blah. Now, regarding in-memory layout, you can store the matrix two ways, row major and column major. Row major means that you effectively have rows laid out one after another linearly, so elements go from left to right, row after row, kind of like English text. Column major means they go columns laid out, blah, blah, blah. Now, here's the fun part. There are always two ways to store a 3D transformation in a matrix. As I mentioned before, he stores a coordinate system, blah, blah, blah. You multiply a matrix. Yep, so this is what I expect. However, you can also store these vectors as rows, and then you'll be applying a row vector with a matrix. Haha! Okay, so this is where I was like confused. So if you expect this convention, but they're doing this convention, it looks like, I guess we don't know which one it's going to do under the hood, but they're saying, so convention 1 appears in mathematical text, convention 2 appears in the DirectX SDK. So if you're using convention 1, then your matrices are column major. Nice. Which one is column major? This. Okay. So this guy's lining up with what we just experimentally found, right? He's saying that they are column major, but only like the ordering depends on which way you think of the multiplications, and that makes sense. Because you could store your vectors of like XYZ as rows or columns, and then you just have to like flip which way you multiply by. Okay, that makes sense. So we'll just put true here. It's like the end result of that. When did you learn programming? I've been probably programming for like 15 years ish, right? I picked it up in high school a little bit, but I wasn't really doing like a lot of it until university, probably. I don't really remember. It was a long time ago. But I did go to school for computer engineering, which helps. So, got like years of work experience and years of schooling in there. Although I would argue that the schooling is it's helpful, but not necessarily required. I would say everything that I learned in school you could pretty easily learn by yourself. With like, well, easily is probably the wrong term. It's like very accessible even if you have to practice a lot, I guess. Okay, so we have this translation, and so let's do let's do our like add back in a rotation around something, and we can do the rotation after the translation. And let's kind of see what that looks like. And we should see something interesting. And somewhere this guy has to be combined as well. Okay. So that's something. We're definitely seeing, what are we seeing? So we're trying to rotate around the vertical axis, but after translation, and that's really odd. So we're seeing like the center of rotation kind of move over time, I guess, at a different rate of our thing, because the center of rotation is not like, this will look a lot nicer if we don't clip it, but instead we do like if we ping pong him, instead of him like going like to the right and then jumping back to the middle and going to the right again, if we somehow animated him like ping ponging, our like animation would look a lot more reasonable. So I guess what we should do is as this number is like monotonically increasing, he's going to be like 0, 1, 2, 3, 4. And if we want to map this in the range of like, we kind of want to like make a, sorry, let's draw it. So he's basically going to be like looking like this, right? And we're kind of trying to turn that into a function that looks kind of like this, right? Like kind of like bouncing back and forth. And so I guess you could imagine this as like, there's some sort of like absolute value going on in here, right? Because like if you have like a function that looks like this and you absolute value him, he's going to now look like this. But then there's also some sort of like, I'm actually not sure that's right. Not sure that's right. Why is this so hard in my head? This seems like, so there's like 4 sections. There's 1, 2, or maybe 2 sections. There's like the downward section and the upward section. And each of those 2 sections do look like an absolute value, right? You could imagine this guy as this instead. Okay, so that's lining up. So we have an absolute value that spans 4 probably, and then we just subtract the 2 to get that other thing that we wanted. That seems right. Maybe he spans 2 wide. So this goes from -1 to 1. Yeah. So we will. Oh, but this is like probably like a 4 long segment, right? If this is -1 to 1 to -1, that's 1, 2, 3, 4. Yeah. So we'll f mod by 4. And then we will subtract 2 and absolute value him, and then subtract 1 again. Maybe? I'm not actually sure about this at all. Like, at all. So let's just kind of print out the movement if I do that and see what we get. We're seeing 1, 2, 3, 4, 1, 2, 3, 4. So that's not what I wanted at all. Maybe I wanted to mod 2. 1, 2, 3. So I'm never getting like the downward section that I expected to get with my absolute value. Which is interesting. Let's go back to just mod 4 minus 2.0. And maybe I've got my brackets in the wrong spot. If I do this, I should see him moving from -2 to 2. Oh! We need to absolute value the rotation. This is moving in the wrong order. So we're going to absolute the rotation in degrees that we're always going up. And now we're seeing a movement from -2 to 2 like I expected. Cool. And so now we can absolute value all of that. F32 abs. And now we should be seeing a movement from kind of like 0 to 2, but going up and down. Yeah, so he comes up to 2, then down back to 0, then up to 2, then down back to 0. Sick. And then if we subtract 1.0, now we should see his X position bouncing left to right. Which we're seeing, but with like a weird X rotation on top. So let's go back to only rotation, only the translation. So he's bouncing from -1 to 1. I don't know why. I feel like he shouldn't be centered in the screen that way then. Oh, because I absolute valued his movement again, which isn't what I wanted. There we go. That looks reasonable in terms of movement. And now if we tack back on the rotation on top, do we see something interesting? Do we see something that like is congruent with what we expect to see? He's kind of rotating around this like... Yeah, that looks kind of right. So we can imagine that there's like this like center of rotation that's moving across the screen, and he's moving around that center of rotation. I think that looks right to me. It's really hard to say without like seeing the front and back and stuff as well, but I think that kind of lines up with what I expect. So we're seeing, I think that we'll keep going, assuming that our transforms are working correctly and we understand how to interact with them in OpenGL, which is pretty cool. Let's say that that's ready to go. And now let's kind of think about, what if we wanted to move the camera around instead of the object? So usually they actually would call this like the model matrix. When this like 4x4 transform, they call this model because it's like how you transform the model in the world. You can imagine like you have like your like 3D coordinate system. Actually, it's probably easier to show this in Blender, right? You can kind of imagine that like the world is like this like defined area. And if I move this guy up in the world, he's like actually been moved, right? But if I'm like looking from the perspective of my camera, now all of a sudden like I'm seeing something different than what the world is, right? And so there's also a like transform that basically says like take the positions of the world and map them into my camera. And so it's pretty typical from what I've seen in like naming is to call the first thing, like where I am in the world, they call that like the model matrix. And then they call the second thing the view matrix. And then I think that there's also something called like a projection matrix. And I'm not sure if projection matrix is only related to like mapping onto two-dimensional surfaces, or if it's the same thing as the view matrix, or if those two things are combined. But basically we should come up with like a second mapping of like where the camera is relative to like the world, and find everything's position relative to that location. And you can kind of think of that as like my camera, if my camera is fixed at the origin of the world, like if I'm, how do I say this? My camera, in terms of like how like OpenGL views the system, right? My camera's kind of like always here, pointing in the same direction. And like moving the camera backwards so that he can see this head is the exact same thing from his perspective as moving the head down, right? You just have to do like the inverse movement of the camera to every object in the world, and then it looks like the camera moved, even if it didn't. And so like there's this sick video that I watched one time. In video games, the camera never moves or something, or the player never moves. This video. Purdy's chocolate. I can skip this ad. God, what? No, skip.
I'm playing.
Yeah, this is the one. So this guy does like some like pretty sick visualizations, and he like builds up this idea of like 4x4 transforms and rotations and stuff. But what I was looking for like, he does this like sick animation where he warps the whole world to match what the camera look like. Anyways, if you're like getting into like 3D and like video games, I'd like highly suggest this video. Anyways, so yeah, from my perspective, me, the camera, the world moves, I don't. And so we just have to define, if we know the camera's position, we can just kind of like, or his transform that also contains like his rotation and stuff, right? So he's here. We can invert that and like just apply like the opposite transformation. And so I was looking up like how the fuck do you like invert a 4x4 matrix, i.e. like get the opposite thing, and apparently it's not trivial. So I'll probably end up just copying this function like bar for bar, and then seeing if that works. See if that works. Yeah, that's probably what I'll do. And then like, or we could specify all of our camera movements just like backwards, and that would also be fine. Depends on what we want. Oh, what is a Wayland on the task manager? I forgot to put this in the right spot. This is supposed to be a keyboard overlay that shows what I'm typing. I usually put this in the corner here. He's usually stuck above everyone. Any tips for new programmers getting to the field? It seems daunting. I think probably just practice. Find something simple that you want to fix, automate something, and just like start typing and like Googling problems until you figure out how to do it. Yeah, no, it depends on like exactly how far you are in. If you're like at like 0, 0, nothing, you know, absolutely nothing, you might need to do a little bit of like how to use Python. But yeah, I think practice. It's always practice, and just finding something that you find interesting enough to practice on. In my opinion. Okay, so let's think about. Okay, so say we wanted to move the camera around in our world. The most useful thing to do is keep asking why something looks or is written the way it is and do a deep dive into everything related to that. Yeah, I'm a big advocate of every time you don't know something, just keep asking why until you are like satisfied with the answer. Yeah. Okay, so we have like this object. It might make sense now to like abstract away the camera, right? We might want like the camera to be its own object. Maybe we have, right now we kind of have like this concept of like a renderer that's tied to one object. Maybe that doesn't make sense either. Maybe we want a renderer that renders the world and can be fed objects to render. And then one of the things that you can do on that render is set the camera position and he will adjust everything accordingly. That seems reasonable to me. Like if I see a piece of code I don't understand, I just ChatGPT and have it explain till I get it. That's like one way. You have to be careful with ChatGPT because ChatGPT is wrong often. But for like simple program, like for when you're at the start, it should be right often. And I would argue that looking at code when you're brand new is probably, well, I guess it depends. I wouldn't like go browse random code bases necessarily, but it's hard to get back into that frame of mind because it was so long ago. I think I would go about it more of like, how do I do X? Googling like, how do I make a program that does this? And if it's like something that's simple and common enough, you'd hopefully get somewhere. But what do I know? Last time I tried to learn programming was 15 years ago, so yeah, I don't know. I don't know if my advice is very good or not. Okay, so let's say that I have a renderer. He can render many objects and move the camera around. Maybe it makes sense first actually to start trying to render multiple objects instead of just one. Let's do that. So let's say that we're at 4750 into stream and we want to say update renderer to handle multiple objects. So probably what we're going to want to do is we're going to want to like essentially have an object that is both a mesh, which is like a chunk of like a bunch of vertices and faces. He's a mesh as well as a transform. Those are like the two pieces of this puzzle that we have so far. And then once we have our mesh and our transform, that's all we need to know to render the object. Eventually we'll also need to know its like textures and its materials and his like normals and all that. But for now, all we need is the mesh and the position or the transform. And then what we probably want to do is we probably want to one time convert that transform into something that is already on the GPU, right? Once we have this guy, we probably don't want to like upload our sets of vertices to the GPU every time we render. We only need to do that once. So probably we need a way to ask our renderer to like give us vertex buffers and array buffers. That seems reasonable. So we're gonna need some struct that holds the mesh as opengl buffers, as well as transform. And then we can pass that guy as to our renderer as something to render. And our renderer will also need to hold like camera position. We'll get to that later. Okay, so that seems reasonable. So maybe, and for each render call, we're going to have mesh we're gonna pass in the mesh, the transform. Is that it? Yeah, that seems reasonable. And like, okay, so I guess this guy is gonna turn into, from like a cube renderer into like a generic object renderer, mesh renderer we'll call it. Is this gonna be a ray tracer too? That's a good question. I can't imagine that we'll like. I've always wanted to do one of those ray tracer from scratch things, so I find it very likely that we will end up there at some point. But I'm not. It's hard to predict what I'll be interested in 3 weeks, right? Like, who knows? Not that I'm gonna take 3 weeks to get there, but I think it's likely, but not guaranteed. I just discovered your YouTube channel. I didn't know you streamed here. I gotta do a better job of advertising that then. I like link it in all the Twitch descriptions and I say at the end, but maybe it's not clear, but happy to see you here. Okay, so I guess our mesh renderer, he's going to, if he's converting meshes into OpenGL buffers that are going to be used externally, right now we're kind of doing that up front. We don't have to do that, so our constructor, he's not going to take in a mesh anymore. Which means that this like creation of buffers, all of this stuff, our like array object and our buffer object and our element, or like element buffer, all of this is going to end up being somewhere else. But he is still going to like compile the program that he's going to use to render stuff. That's still all relevant. He's going to use that unconditionally. All of this like setting vertex attributes is also not going to be done here anymore. But finding where we're going to put these guys is, I think. Yeah, that seems... So we're going to get these locations that are like basically pointers to... Well, not pointers. They're like indexes of like inputs to our shaders. We're still going to need all of those. Okay, and so we'll delete anything related to the specific object, which is these. All of these guys are still part of it. And then we're going to have like some struct that's like opengl GPU mesh or something, right? A mesh that we've put on to the GPU in OpenGL, and he's going to just have those guys that we just deleted from here. So the vertex array, the buffer array, and the element buffer, which we didn't actually store here. So all of these guys are going to be part of him. And basically, we're just going to take all of this code that we previously had in our new function, and we're going to say pub function upload mesh or something. Which I don't know is like if that's like the right terminology. But in my head, the way that this works is you have a bunch of vertices, and when you call like, hey, when you call this like set buffer data, my understanding of that is like copy pastes all of the vertices from like the CPU and it pastes them into the GPU. And so that's why I'm considering this like an upload, is because it's like putting all of the vertexes into the GPU. That's how I'm thinking of it, at least. And he's going to take back, he's going to return a GPU mesh. And he's just going to do all this shit we commented out. Essentially. And this like reference to GL he has inside him, so he's going to say let GL is equal to self.gl. A bunch of this shit's unsafe, so we're just going to say unsafe here because we're interoperating with C code. Very dangerous, very dangerous. So throw this on here. This question mark operator no longer is relevant or is no longer usable, so we're going to have to say that this guy is going to return a result that could be a GL error if he fails to create some of the things that he needs, which means that, and then at the very end, we just return our GPU mesh, who has VAO, VBO, and EBO. And I guess, of course, he's going to have to take in a mesh to upload. Okay? And then, otherwise, I think everything else just kind of works out. we didn't store this vertex location, which we need. So we'll just say vert look goes here, and he goes here. And now he's not a uniform location, he's something else. Attribute location. Probably at location uniform location. What is he called? Okay, so this is called get attribute location, which it comes from this like opengl bindings thing. And so we'll just see what he returns. Get attribute location. He just returns a U32. Okay. Okay. U32. Alright. So somewhere we were like creating vertex arrays. We don't need these either. When we create and bind, oh no, that's right. That's right. All that's right. Okay. So then when we render, we're gonna take in our like GPU mesh to render, and later we'll take in the transform too. But for now, we'll just take in the GPU mesh. Random question: have you ever worked with Vulkan before? I'm running graphics programming, and I want to be able to add new APIs to your custom engine. Would this be more work or harder to implement? I've never worked with Vulkan. I imagine, like, I kind of think of like the progression of this is gonna be, well, not this particularly, but like open like 3D programming. You have like your game engine, right? You're using like Godot or something, and then like if you want to get like a little closer to the machine, you're gonna write like OpenGL, and if you want to get even closer, then you're gonna write Vulkan. And so I would kind of like to understand like the OpenGL side of things, and then at some point dive into Vulkan. I'm sure that I will do that at some point in my life, but haven't done it yet. How do you get to the point to be able to build something without having to look stuff up as you make it? Oh, I guess I wasn't really clear earlier when I was talking about that. I think that you should look stuff up and read it for sure. I think that I just think it's easier to look stuff up that's related to something you're building, I guess, instead of like Googling like random code bases and browsing through them, right? If I were to just like open up like, you know, as an example, if I'm like, I want to look at like the Clang compiler and look at like what do they have in here? Like browsing this project with like no background on what they're trying to do or like why they're making choices they're making. Like as soon as I start getting into like it's hard to find an example, but I've browsed some of these codes before and they can get like pretty complex and pretty difficult. So the reason I was suggesting like building something yourself is it'll stay simple, and you'll kind of like add complexity as you need it, and eventually you'll discover reasons why people add complexity in ways that they do, etc. But yeah, I think definitely you have to Google stuff. Just I would start by Googling related to a project that you want to work on. But that's just my recommendation. What do I know? Okay, so here we're going to bind in the meshes stuff instead of ours. And probably when we're done all this, we want to unbind the buffers that we used as well, just to be sure. So we'll unbind the vertex array and then bind buffer flow element array buffer. Just do some cleanup here. And this is probably the array buffer. None. Okay. So we take in the mesh, and eventually we'll take in the transform, but other than that, the mesh will also have to keep track of how many elements or how many vertices it has, so we'll just call it num elements. We'll store it the same way we did before. How many things are we going to render? Num elements, I could do noise, and then we take mesh.num elements instead of our self.num elements. Very nice. Okay. And here we'll say try into expect too many elements. Too many. Okay, so now all we have to do is, instead of doing what we did before and pass the mesh in as part of the construction of the mesh renderer, we will construct our mesh for our little Suzanne monkey, I think is her name. I think that's what they call her in Blender. In the Blender land. So here, before I was passing in the obj as part of the cube renderer. First of all, it's not a cube renderer, it's a mesh renderer now. Cube renderer is now mesh renderer. And we don't pass in the object now. And now we just say let Suzanne is equal to mesh cube renderer dot upload mesh Suzanne, or our object, I guess. And we unwrap this, and then we should be able to render Suzanne every time here. So if I target run, hey, that went surprisingly. I expected that to be worse. Okay, so now theoretically, I should be able to add 2 Suzannes at different positions. Yeah, look at that. Okay, so that's pretty cool. So now our renderer is like supporting multiple objects at the same time per frame, which is pretty sick. Pretty sick. Cool, 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 cool. So we'll call that done. And we're at 01, 07, 55. And what are we going to do next? Camera stuff, I guess. So I guess the thing to do here is we can now... I guess we're not going to do camera position, actually. I lied. We're going to do arbitrary object transforms. Yeah. And also I got the time wrong again. Classic. So instead of this guy taking in a camera position and rotation, we're going to assume the camera position is fixed. And so we're only going to take in our transform. And he's going to be a reference to a transform. And so instead of doing any of this stuff, we are just going to upload the transform as provided. Boom. Just like that. Which means that in our render thing here, now we're going to have to, maybe we'll say, let Suzanne 1 position is going to be equal to, I don't know. Let's just say that over time, I guess we'll store this externally. And we're going to say her initial position is 0.0. And Suzanne 1 position is going to be 0.0 as well. I guess we'll move one along the x-axis and one along the y-axis just as like a demo to make sure that like everything's hooked up correctly. So we'll say let Suzanne 1 is equal to a transform new. And maybe we should be able to say we should be able to make these guys like from translation, right? Which is going to be an x, y, z, and we'll just like punch them in, and we'll just manually construct this array. So maybe we'll say we will also have a function to give them like an identity, as in like no change, which will just return transform let array equal to he's got 4 things, and each of these guys is going to be like 1.0, 0.0, 0.0, 0.0, and it's just where the 1 is going to be moved. So I guess we'll start by putting zeros everywhere, and then we'll fill it in after. So then we'll just go and we'll change this one to a 1, this one to a 1, this one to a 1. Cool. That's identity. Like this. Cargo check. So that's fine. We'll deal with those compilers later. So from translation, he's going to say let transform is equal to transform identity. Identity, like that. And then we'll just adjust transform. This is going to go into like the rightmost column. And so we need to say that the array at column 3 index 0 is going to equal to x. And this is going to be y, this is going to be z. We'll make this guy mutable and we'll return him. Easy. Which means that now we should be able to say that our Suzanne 1 is going to be transformed from translation. And the first Suzanne is going to be translating along x. So we'll say Suzanne pause 0, 0. And the other one is going to be along Y. Like that. And then here we'll just pass in Suzanne 1 position and Suzanne 2. We're gonna run, and we should see one translating along X and one translating along Y, but instead we see jack shit. So that's cool, and that's because we didn't update her position at all. So we have to say Suzanne pause minus equals time since last as a sex F32 or something. And then we have to do that same like absolute value shit we were doing before. Did we leave that code in, or did we just completely delete it? Let's do this. Yeah, so we'll say let movement is equal to all of this Suzanne pause, and we'll use movement. Okay, so that's not doing what I thought it would do at all, which is bad. Let's only do Suzanne 1, which they don't like at all, because I didn't comment out everything. And yeah, something here is not right. It's not right at all. It looks like when we were not inverting the matrix. So have I made a mistake here? Why is it false now? Oh no. Oh no, that's not good. I don't understand something. That's not good at all. Because before I thought that we had like definitely like come to the conclusion that column major was right. But now we're seeing that we're uploading as row major. And like, what the fuck? What the fuck? Ugh. That's not good at all. Not good at all. But yeah, now this is acting the way I expect it to. Is it? Why is this guy's like perspective changing like that? Oh, because he's looking, we're looking at the top of their head. I see. Okay. Well, I don't really, I feel like I really should try to understand this, like, column major order shit. Oh! It's because I fucked this up. Is that true? This should be YX, so I should be doing... Oh my god, let's just print the transform. Because I think that this should be 0, 1, 2... Oh! I was doing it wrong. Nice. So I fucked up the order of like where I was doing. I did 3, 0, which means I'm iterating row first, and I inverted them here. So it's a good thing that I didn't just go, oh, if I flip it, then it's right. And instead I double check this because otherwise we would have been up for a pickle later. Okay, so this goes back to true, and we should see our Suzannes bouncing away the way we want them. Perfect. Perfect. All right. So I think that we have said that arbitrary object transformations are now ready to go. And now we should be able to add in camera positioning. So we can call this like set camera transform. Maybe. And we'll take in the transform. And we will then, in our vertex shader, I guess, we will accept a second transform, and we will just apply that. That seems reasonable to me. So here, we'll say that this is the model and this is the view. And so anywhere we have transform right now, we set this to model. And then we just also, once we have the model position, then we just apply the view transformation as well. And then it would be kind of fun to do something like, I guess we need to double check. I think in our vertex shader, we were doing something, we had this camera pause Z variable, so we'll just get rid of that. And oh, we still need to apply perspective. So in our case, we're just dividing our X and Y by Z. So once we're in view space, we should still be able to do that. I think. We'll find out. That might end up looking like really fucked up, but we'll see. We will see. This is also assuming a 90-degree view angle. We did the math here the other day, and it just turns out that way. But I think what people often do is they make like a projection matrix as well that you can like specify like skews and like distortions and stuff. But we're not dealing with that right now. Our perspective is very naive. All right. So I guess we just have a view location that we stash. So first of all, this transform is now going to be model. And we're going to rename this to model location. And we're going to rename this to model location. And then we're just going to now also keep track of the view location. Oopsies. So this is view. This guy takes in view. And then we save the view location. Easy, easy, easy. Which means that here, when we get in a transform, we just do the same thing that we did here. I guess all we do is we upload. So we say self.gl, this is unsafe, we don't give a shit. We're going to upload to the view location the transform that they give us. And that's it. That's it. Nice. Probably. So let's try setting the camera position. So we can run once with it just set to like let camera position is equal to transform from translation. And we'll just move him one back along Z. This. And we'll say cube render, which is not the right name anymore, but we'll have to fix that. Set camera transform to camera pause. Okay. And so here we fucking crash, invalid vertex shader, rust backtrace equals 1. He's bitching at line 40 of cube renderer. So he doesn't like camera pause Z, but that's okay because we don't use that anymore. So it's actually correct. He should crash because that doesn't exist in our vertex shader anymore. And so this is invalid. All right, run him again. So I think that we've actually moved we've probably moved our camera inside our monkeys, which is probably why it looks like that. That's my guess. So I think that we just need to put our translation the other way. No, he's definitely just fucked up. Oh no, I guess if we just weren't applying the view matrix at all, that's what we would see. So how do we test that? How do we test that? We could double check. So let's get rid of all movement for now. We'll render one Suzanne in the center of the screen. In the very center, 0, 0, 0. And we should be able to position our camera in a way that she doesn't look fucked. So here we see nothing. But we did move one over to the side. So let's go back to 0, put 0 here. So does setting negative or positive 1 have any effect? No. But also we're seeing total black and our clear color is gray, right? So if we don't render Suzanne here, actually, I think that we should see gray, not black. Okay, so that's good. So it means that we're seeing Suzanne just very cover the screen. What if we move ourselves like 50 meters away? Just get the fuck out of here. Still black. So that makes me think that this camera transform isn't being applied. So maybe... oh, because we're not using the program. Nice, nice, nice. So we need to say, hey, apply this, but for this specific program that we're running. Okay, so now we're seeing gray, which is good. And let's try going back to like a reasonable distance from Suzanne, like maybe -1 meter. Or maybe +1 meter. Okay, so now we're seeing something. Which one of these makes her bigger? I actually don't know. Let's add some movement again. Let's add some movement. Okay, and if I get closer now, or I put this at 2.0 instead of 1.0, she's gone. And if I put this at -2.0, she's also gone, which makes sense because the clip space is actually -1 to 1. But we haven't accounted for, so like if this is my camera here, say this is like my camera, he's got like a little lens and like you know, this is my camera. We are like basically taking like a world, like this is like my field of view. We're kind of like supposed to take the world and like cram them into this box like this. But we're not ever adjusting the front and back of these guys. So we can only render things that are between -1 and 1 right now. Eventually we'll have to fix that. And that's actually part of the view matrix, usually, is setting those clipping planes. But for now, let's just set them to -1. Okay. So definitely -1. I think it makes them smaller, but I'm not actually sure. I'm not too sure about that, but that seems okay. Let's try rotating the camera now around this, and maybe we'll start to see something that's like kind of interesting if we do that. So we'll make another from rotation, or we'll say like from Euler angles, where Euler angles are like this way that you can specify rotations of an object. So they're actually here, XYZ Euler. So the way that these guys work is you define like a rotation around the x-axis, then the y-axis, then the z-axis, and you can I think get any rotation out of those. It's hard. It's not clear sometimes. How do I say this? My brain's melting. Why am I just freezing? You can get into this thing called like gimbal lock, where like some rotations are hard to express. Like if you align some of the axes, they get kind of stuck. Can I give an example? So I'm not finding one, but there are reasons that you don't like Euler angles, but that's okay. For now, we will say from Euler, and maybe I don't even care about from Euler. Maybe I just want to say from axis angle. That's probably nicer. Nice. And we'll say the axis is going to be, we're just going to predefine the X, Y, and Z axis, because I don't want to handle like arbitrary axis angle rotations. And now we can just say that we have an angle as well as a axis. And which axis we're rotating around basically defines which of these like 2D rotation transforms that we're constructing. But so we'll say match axis. Well, I guess we'll do the calculations first. So we'll say let A is equal to, I guess let CX is equal to cos F32 cosine angle. And then we have sine X is sine angle. And then we've derived this before, maybe even in this stream. I don't really quite remember if we did it here, but we're essentially making this. Where do I want to go? I want to go to rotation matrix, Wikipedia. We're basically punching in this pattern, which is like cos, negative sine, sine cos, and that determines the rotation. And so we just have to decide where to slot it in based off which axis. So we will match the axis. And if we see axis X, we are going to put it somewhere. Y and Z. So if we're rotating around axis X, X shouldn't change. So we're going to put it in the bottom right. So I think it goes, X will look like it's down here. Y will look like it's like this. And around Z will look like this. So around X, we're going to say we have 0, 1. So you're going to look at transform array 1. 1 is going to be cos X. 1, 2 is going to be sine X or negative sine X. Negative sine X. Array 2, 1 is going to be sine X, and 2, 2 is going to be cos X, I think. And now we just do the same thing for Y, but 1 is going to turn into 0, 0. That's 0, 0. This is 0, 2. And then we have 2, 0, and 2, 2. Nice, okay. And then for Y, it's in the top corner, so we're going to have 0, 0, 0, 1, 1, 0, 1, 1. Nice. Nice, 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 nice. And that should be it. So let's say that we want to spin around the vertical axis, which in our coordinate system I think is Y. We should be able to say camera position is this multiplied by a transform from axis angle. And we're going to say that our angle is 0.0. And I guess we actually have to define, we want this to like be animated. Well, no, for now we can just hard code it. So we're going to say like some rotation around axis Y. And we'll just see where that takes us. Cargo check. He's mad because axis is undeclared. It's not accessible, so we need to go back into here. And here we have to say this is a public enum. And here we have to say mat axis. Okay, so what we should see now is... Okay, so I don't know why the fuck our background... Oh, because Suzanne's like ending up inside the camera. Let's keep Suzanne still for a second. Just to see. So here we'll just use identity as her location. And we're rotated. We're somehow seeing nothing. And that's because our rotation is probably... let me think. Let me think. So we're like in 3D. We're like starting our camera in the center of the world. We're moving her back along Z. So we'll say that this is Z and this is X. So we're moving the camera back and then we're rotating it. So if it's looking this way and then we rotate, it should end up over here looking this way. And so the question is, why is that not happening? So let's start with a 0.0 and we see what we expect to see. And let's just like increment this a little bit and see if we start to like rotate. So the fact that they're not rotating in the center of the screen is very odd to me. So is it possible that we got this from axis angle wrong? We start with identity and then we adjust 0, 0, 0, 2, 2, 0, 2, 2. And I'm not seeing... Okay, let's try a different axis, a less complicated one. Let's try x-axis first and see if that looks reasonable. Okay, so no rotation, a little bit of rotation. And let's try maybe like, I don't know, like a little more rotation. And it's like, where did it go? Because like if it's rotating around the x-axis, it shouldn't go anywhere. So we're fucking something up. So what does this rotation matrix that we've made look like? This is odd, right? We're seeing movement that I don't expect to see here on like the fourth element here. Oh, and it's because we're moving first. Oh, but that should be fine. Let's go like this first. We will only rotate. Oh, if we only rotate, then we're not in the right spot. Is it because order? We've like fucked up order somehow? Do we rotate first, then translate? I would think that if we translate first, the rotation should not affect anything too significant. Am I high? Let's cargo run this again. Yeah, so I don't understand. In Blender, like, say I have this guy and I move him we move him like backwards along Y, and then we rotate him along Y, but we rotate him around like the center of his thing. So we rotate him around Z. Like, this is what I expect to see, is like our camera. Here, let's clear our camera location. How do I see this in like, okay, yeah, X and Z. This is what I want. So I'm expecting us to move the camera back by some amount and then rotate him around like this. But that's not what I'm seeing. So I'm missing something. I'm definitely missing something. And so like in this scenario, say we rotate him around, I guess his X and Z positions should be changing, but his Y position shouldn't. So what am I missing here? X, he's getting no translation, but Y, he is getting translation. What if I'm rotating? Oh, I'm sorry, I'm rotating around X. So X getting no translation, that's correct. Y is getting translation, Z is getting translation. Seems reasonable. This is the lookout matrix. I understand. Like, I've heard that before, but like I would think that doing a rotation and translation should end up with the same thing, right? Like if I create like an arrow. Right? And we'll say that like this arrow is pointing where the camera is looking. Right? Like doing this rotation and then rotating him around the center, I should still look at the same thing. The camera does not move in OpenGL, you move the world. I understand that. I am moving the world according to a view matrix of the camera, right? Like in my renderer. Also, like here, let's see. So here, I'm applying like a view transformation after I set the model position. So if my view transformation is specifying like a rotation. Oh, yeah, it is backwards. Yeah. So the order of operations here is actually wrong. So if I move the world, I need the world to rotate. So if my camera is always at 0, 0, 0, and I rotate things in the world around 0, 0, 0, if I think that I'm moving the camera back and rotating this around this point, what's actually happening is like everything in the world is rotating around my 0, 0, 0, which is wrong. So I think I just have to do the operations in the opposite order. And that would do what I want. From axis angle. And so this is probably why we actually would need to calculate inverses. In fact, let's just do that. Let's just invert the matrix. So we'll do these like two operations that we expect. And is I can't remember which way I want to translate here, but we'll figure that out in a second. I think probably if I go into our vertex shader and we invert the view matrix, that might behave a little bit more sanely to me. Let's rotate this like 2 now. Yeah, okay. And this probably needs to get turned into +1 now, probably, because everything's backwards. Okay, cool. So now if we animate this guy, we'll say camera position is this, and we will say we'll do the same thing. We'll just use Suzanne pause as the camera pause for now. And then we have to set the camera transform every frame as well. We should see rotation around the y-axis. Nice. Nice, nice, nice. And now let's, or the x-axis. Let's go back to rotating around y, and we should start seeing, yeah, there we go. Something's clipping out, which is a little odd. Maybe this guy, like, what is my transform supposed to be here? -1. Both of these are like clipping out, so maybe -1's too far, and maybe we need to go like 0.75. I'm also a little weirded out about why it doesn't seem to matter which direction I move the camera. The fact that I move it forward and backwards and I still see him is probably because I'm not doing like the near and far clipping of the camera. So I probably just have to bake that in. Probably. Yeah. But we'll maybe figure that out later. Okay, so now let's say that I go back to moving Suzanne around. And I'm moving the camera now, independently. Like, what is that? It's hard to tell if that's right. Okay. I think we're gonna have to do like proper clipping of the near and far plane to get a better idea of this. Or no. Here's what we'll do. We'll render 2 Suzannes at 2 different XY locations with no movement, and that should give us something interesting. So we'll put the first Suzanne at maybe like along X, and the second Suzanne at the other direction along X. From translation -0.25, 0.0, 0.0. And now the camera spinning should see the 2 different Suzannes spin differently. There we go. Yeah, that's not too crazy. I don't understand why the alpha, like, all of a sudden we're clipping, like, we're seeing through things that we weren't seeing through before. That's kind of odd. It could be because we're rendering things that are actually behind the camera, and that just might be, like, fucking shit up. Not really sure. But at the very least, the camera is, like, now somewhat moving the way I would expect it to. We could even maybe move the camera. Oh, it's because I'm not applying. Sorry, this should be here. Okay, there we go. It's probably because we were rendering things behind the camera and that wasn't like playing nice. But that's looking pretty reasonable. Pretty reasonable. And then I guess we could even do something like move the camera up and rotate it down a little bit so we're looking at them from like above their heads a little bit. So we could move the camera like up by a little bit in Y. Like 1 or maybe 2. And then just before we do this rotation around the Y-axis, we'll do a smaller rotation around the X-axis. We'll why isn't this? Oh, because I'm seeing behind, like, there we go. So we want to do a small, like 0.2 rotation, or maybe like even higher, like 0.4. I don't know. I'm just guessing numbers here. But yeah, that's kind of neat. So if I increase this number now, I'll probably be looking farther down. So if I like 1.0, I should be looking like more downwards. Yeah. And let's just do like 2.0 just to prove to myself that it really is that extreme. Yeah, that's not bad. Not bad at all. Something about this looks fucky. Oh, it's because I'm looking from underneath and I thought I was looking from on top. Yeah, okay. Okay. I think that's pretty reasonable. So I think we can probably say that we did camera rotation translation. I don't really know when we did this, but we did it at some point. And we didn't do the matrix inverting in CPU code. We're kind of doing something kind of wasteful where for every single vertex, we're inverting our matrix transform. I don't know if like OpenGL is going to be smart enough to batch that in some way. It could be, but I don't know if it is. But yeah, that's pretty sick. So the question is, what next? What next? Maybe we do, like, maybe we texture these guys a little bit. Yeah, let's do that. So instead of these guys just being like blobs, there's a periodic compression of the stream. Anyone else? Is it really bad? Like, is it showing everywhere or just on my camera? Oh, also my camera's really laggy today. Probably because none of the lights are on. I'm gonna go turn on some lights. Be right back. All right, sorry. That's one problem solved. Now, how about the compression artifacts? They're only on my face. Oh, they are on this guy too. So it's like once per second, they just get like hella compressed. Yeah, that's annoying. It's probably my compression setting, so I'm limited to like 6,000 bits per second, and I'm just using like my GPU's built-in constant bitrate. And so probably what it's doing is every iframe, it goes like, oh shit, that's a lot of bits. Because it's too fucking stupid to predict that it's going to have to retransmit all data, probably. So I'll look into that at some point, but I think for now, unfortunately, we might just have to live with it. Unfortunately. Okay, so I want to do some form of texturing. So the idea would be, let's open a new project. And let's maybe get Suzanne back in here, but smaller because we're not really sure about objects. How do I say this? If she's bigger than 1.0, things will be a problem. So we're going to set her origin to the center of mass. We're going to clear her location, object clear location. And let's look at her UV. Let's like, we already have a nice UV unwrapping of her. So all we have to do now is if we want her to look a certain way, we just have to color in this texture and then save it somewhere. So, let's start by just like, can I draw on this? Paintbrush, red, everywhere. Why can't I draw on this? Maybe I need to make a new image. 1024 by 1024, nice, okay. So let's do something like, I guess monkeys are kind of brown. So we'll paint her brown. Wop. Okay. And then, do I have to save this picture somewhere? Image, save as, work, start screen, Sue's texture. Okay, and then somehow I need to like make it know that I'm trying to use this texture. So I guess new, and then I go into like this texture view, not texture node, shader editor, and then I like use that image texture as her color. So now when I go back into texture paint, nice. So now we can like paint her eyeballs with like white. Right, we can like, you know, give her a little eye whites and maybe even some eye darks. Maybe. I don't know why it's not coloring. Oh, I guess I need to like fucking get in there. Can I just do this? Paint it over here. Yeah. Oh, I see. There's more of them over here. Okay. That's good enough. Maybe we give her like a pupil or something. None of this really matters, but right, because we just want to see that like we're seeing something when we get this in to OpenGL. Yeah, that's probably good enough, right? Maybe we color the inside. What are we color like in mouths? Red, like kind of like red. Maybe she's wearing lipstick. Oh my god, it looks terrible. Like she ate a crayon. Oh my god. But okay, that's fine. So we'll save this image. And now when we import our object, we're actually going to need to import its texture coordinates as well. So it looks like, if I understand this correctly, we should see UV coordinates in our Suzanne obj file. So if I go back to my terminal and we look at like res, where do we store this? We called it cube.obj. We'll fix that later. So this object format says like, here are all of our like vertices, and here are all of our faces. But the faces should also have texture. Yeah. So there are normals and texture coordinates, I think. VT probably stands for texture. So we can look at like obj file format. And in here, I think it said VT is texture coordinates. Yeah. So what we can do is in our obj parser, we can now say pub text chords is going to be a vector of two-dimensional floats to specify like basically like for each vertex, what is going on there is it's saying like each vertex will map to like a specific point on this. So like if I like select these 4 vertices, those vertices like show up over here. It's hard to see, but they do like kind of show up in the image. And so it's like, where in this 2-dimensional image does this vertex map to? In normalized space from 0 to 1, if I understand correctly. So we're just going to say, well, we're parsing this thing, and as we parse faces, let's also parse texture coordinates. We'll say parse text chord, and then we'll say we have text chords. We need to parse those. And we'll text chords push. And then here where we parse the vertex, it's going to look very similar here. Instead of parsing a vertex, we're going to parse a text chord. We're going to expect 2 elements, x and y, so we have 0 to 2, and we're going to say here, instead of missing vertex, missing text chord, non-float vertex, non-float text chord, non-float vertex. We don't have this like extra third thing to parse, so it's just, we're parsing 2 floats, easy peasy. And we just need to add in those, we're going to say in here, vertex is replaced with text chord. And now everyone should be happy. We expected F322. Nice. Okay. And so now we should be able to say text chords. And I think somewhere we're printing out our Suzanne model after we parse her. And if not, we can. So let's just do that. We'll say, let's see what we got out of here. Obj. Can I just print the text coordinates, actually? Let's just see them. Master Keebs, thanks for the sub. We're printing something somewhere that's taking up, like, tons of screen space. What are we fucking printing? Mesh. Oh, okay. So that is what we're looking for. So our texture coordinates are being parsed, which is good. And now what we need to do is our faces. These are parsed as like vertex coordinate, texture coordinate, normal coordinate. So we should parse the first thing after the slash. And if we see something after a slash, then we should interpret that as a texture coordinate for this face. And then we're going to have to upload those texture coordinates to the GPU in some way, as well as load the image and project that onto the guy in some way. And so I'm looking at that amount of work, and I'm thinking that's a lot. And probably it makes more sense to try to cover that tomorrow. So, when we come back tomorrow, we're going to associate each face is made of 3 vertices. We're going to have to match those vertices to texture coordinates, upload this GPU, project the thing on. And then if we finish that, I don't know, we'll figure out, we'll have more work to do for sure. So I'll just have to figure out what I want to do next. There's a lot to do with like, once we load multiple objects, like positioning them in the world, how are we going to handle that? How are we going to handle like arbitrary like texturing of stuff? Like we're going to want to write a custom vertex shader or custom fragment shader for the monitor. And we have to think about that. So there's lots more to do. I'm going to call it there. Yeah, thanks for watching. If you liked what you saw, I stream every day for around 1 or 2 hours at around 1 or 2 o'clock Pacific time. We've been working recently on like 3D OpenGL stuff, but we're going to do other stuff as well. We're going to jump back onto an operating system at some point. I have an idea for some like AI stuff I want to do, so we're going to try to cover a variety of stuff. I have a YouTube channel, so if you miss a stream and you want to catch up on YouTube, there's a YouTube link in the Twitch description. And if you're watching on YouTube and you want to swing by, say hi, chat, whatever, there's a Twitch link in the YouTube description. Thanks for watching. Catch you guys on the next one. Bye!